Hi guys, I'm Raul Miraj and I will be presenting my new lecture series channel called Online Maths and Science. You are watching my Introduction to Algebra lecture series, and in this video I'm going to be talking about real numbers, which are rational, irrational, integer, natural, and whole numbers. So let's get started. So real numbers, they are classified as rational numbers and irrational numbers. There are three types of rational numbers: whole numbers, natural numbers, and integers. Rational numbers, they are numbers that can be written in the form n over d, where n represents the numerator and d represents the denominator. N can be any number or any integer, but d cannot just be any number. It cannot be zero. And the reason for this is because anything divided by zero is undefined. And there are examples of rational numbers, such as 7 over 10, which is a fraction, or finite decimals like 0.125, 0.333 going, no, 0.333. Then you have 0.284, 284, 284, which repeats. Those are all examples of rational numbers. So if you have fractions, finite decimals, or infinite repeating decimals, those count as rational numbers. Whole numbers, which are rational numbers, they start from 0, as we can see below. Integers, they are also natural numbers, which are also a second kind of rational numbers. They start from 1, as we can see over here. And integers, they are positive and negative numbers that can be infinite. They range from minus infinity to plus infinity. We look at the second type of real numbers, known as irrational numbers. Irrational numbers are numbers that cannot be written as fractions, as rational numbers can be written as. And examples of irrational numbers would be pi, or decimals that are infinite but do not repeat, or the square root of 3, or any imperfect square. If you have non-repeating decimals or imperfect roots, those are all examples of irrational numbers. Now that we know what rational and irrational numbers are, we can identify them. So in this example, I'm going to ask you to classify the following real numbers as rational or irrational. So here are 4 examples: A, B, C, and D. I want you to pause the video and work it out. So in A, we have 5 over 4, which counts as a rational number because it's a fraction of the form n over m. In B, we have a non-repeating infinite decimal, therefore it is irrational. In C, we have a repeating decimal, 456, 456, 456, 456. Therefore, it counts as rational because it's a repeating infinite decimal. Lastly, we have a finite decimal, 0.1235, which counts as rational because it's a finite decimal. So in summary, real numbers consist of rational and irrational numbers. Rational numbers are fractions of the form n over m or n over d, where the numerator can represent any integer and the denominator can represent any other integer than 0. Irrational numbers are numbers that cannot be written as fractions, and an example of those would be infinite decimals that do not repeat. So in our next lesson, we'll be converting infinite repeating decimals into fractions. We said that they are rational numbers, but how do we get them to be fractions to support our claim? And this brings us to the end of this lesson. I hope you enjoyed it and it was informative to you. Thank you for watching. Give yourselves an applause and feel free to comment or email me at rahulmaraj523@gmail.com if you require to have a consultation with me regarding anything that I've said or anything that you are having difficulties with at school. Thank you so much for attending and goodbye.